Imagine a man who did not just see the future, but drew it with almost prophetic precision. A man who did not settle for painting fleeting beauty, but demanded to dissect the deepest truth, the invisible structure holding the universe together. A man who, in the beating heart of the Renaissance, an era of rediscovery and splendor, dreamed the impossible. He dreamed of flying like a bird, of driving armored tanks and walking undisturbed on the seabed.
His mind was a labyrinth of ideas, a crossroads of disciplines, and his notebooks, his codices, were the map of this unexplored land. A labyrinth written backward in a mirror script that seemed to want to protect his secrets from the world, or perhaps simply a way to keep pace with the dizzying speed of his thoughts. His name was Leonardo, son of Piero da Vinci. His life, long and incredibly productive, was the most striking demonstration that art and science are not two separate paths, but two inseparable faces of the same inexhaustible human curiosity. Born on the 15th of April, 1452, in the small hilly village of Anciano near Vinci in Tuscany, Leonardo entered the world in circumstances that immediately placed him outside social conventions. He was the illegitimate son of Ser Piero da Vinci, a wealthy and respected notary, and Caterina, a woman of humble origins, probably a peasant. This unconventional origin, far from being an insurmountable obstacle, proved to be an extraordinary opportunity. Not being destined to follow the traditional academic path, dominated by Latin and rhetoric, his education was based on direct experience, observation, and practice. While his peers studied ancient texts, Leonardo studied nature. He observed the flight of birds with an almost obsessive meticulousness, analyzed the growth of plants, the ebb and flow of water in rivers, accumulating a wealth of empirical knowledge that would surpass any bookish learning. Nature became his true teacher, and his mind remained free from academic dogmas, ready to question every accepted truth. At the age of 14, his father took him to Florence, the cultural and artistic capital of the Renaissance, and apprenticed him to Andrea del Verrocchio, one of the most influential artists of the time. Verrocchio's workshop was not just an art school, it was a true multidisciplinary laboratory. Here, Leonardo learned not only to paint and sculpt, but also a wide range of mechanical arts and techniques essential for a Renaissance artist, from metal casting to leatherworking, from the chemistry of pigments to the design of complex machines. The artist and the engineer were born simultaneously in a perfect union. His brush was already a scalpel, his canvas a field of study. Every work of art was an optical experiment, every portrait an investigation into the human soul. It is said that when painting the angel in Verrocchio's Baptism of Christ, his skill in rendering the softness of the hair and the depth of the gaze so surpassed that of the master that it drove the latter, out of shame, to abandon the brush forever. This story, perhaps legendary, underscores the precocity and exceptional nature of his talent. Leonardo embodied the Renaissance ideal of the universal man with a completeness and depth that no one else achieved. There was no field of knowledge that did not attract him with irresistible force. From botany to geology, from mathematics to optics, from hydraulics to anatomy, his notebooks filled with meticulous observations and detailed drawings. These notebooks, today known as the Codices, the most famous being the monumental Codex Atlanticus, are the true mirror of his mind, an uninterrupted flow of ideas, sketches, and calculations. His writing, from right to left, was a private code, a way to protect his revolutionary ideas in an era when scientific heresy could be costly. But it was also, more simply, a more comfortable way for a left-handed person not to smudge the fresh ink. Beyond practicality, this practice symbolized his mind, unique, inaccessible, turned in a different direction from everyone else, always one step ahead of his time. While his contemporaries focused on aesthetic perfection, Leonardo was obsessed with function, with the intrinsic mechanics of things. He wanted to understand how things worked, and he was not satisfied with superficial answers. His first engineering projects concerned lifting systems, textile machines, musical instruments, and devices for the theater. A striking example of his futuristic vision is his self-propelled cart. It was not a car in the modern sense, but a spring-driven mechanism, a programmable robot that moved autonomously following a predefined path. It was an anticipation of robotics and automation 4 centuries before the concept took shape. His approach was always that of an engineer who uses art to document and science to create, merging the beauty of the drawing with the rigor of calculation. In 1482, at the age of 30, Leonardo made a crucial decision. He abandoned the Florentine art scene, which no longer offered him sufficient stimulation, and moved to Milan, to the court of Ludovico Sforza, known as the Moor. To introduce himself to the Duke, he wrote a letter that is a masterpiece of pre-literary marketing. Instead of emphasizing his artistic talent, he proposed himself as a military and civil engineer, meticulously listing his technical capabilities. He promised to build very light and easy to transport bridges, to divert rivers, to flood the enemy or to irrigate fields, to create unassailable cannons, and, above all, to design covered and safe armored tanks, capable of breaking enemy lines. His ability to describe war machines was so vivid and convincing that it immediately secured him a prominent position at court. His armored tank was an armored dome, equipped with cannons on all sides, moved by men inside through a system of cranks and gears. Although the original design had a flaw, with the internal gears designed to move in opposite directions, an error that some historians believe was intentional to prevent the weapon from being built by others. The idea of an autonomous armored vehicle was absolutely towsome, revolutionary. And then there was the 33-barrel cannon, a rapid-fire weapon that could shoot in sequence, the conceptual ancestor of the modern machine gun. Leonardo, despite being a convinced pacifist, understood that war was the engine of technological innovation, and he used military necessity as a pretext to finance his scientific and engineering research. In Milan, Leonardo did not stop painting. On the contrary, he created 2 of his most important masterpieces. The first is the Virgin of the Rocks, where he perfected the sfumato technique to create a mysterious and enveloping atmosphere. The second, and perhaps the most famous of the Milanese period, is the Last Supper, frescoed in the refectory of Santa Maria delle Grazie. This is not just a painting. It is a masterful application of mathematics and optics to create perfect perspective and a dramatic composition that captures the exact moment Christ announces the betrayal. Every gesture, every expression is studied with a psychological and anatomical precision that goes beyond simple artistic representation. But his work in Milan extended far beyond art. He dedicated himself to civil engineering, designing systems of canals and locks to make rivers navigable, such as the Naviglio Grande. His locks, or basins, were not just a technical improvement. They were a system to connect cities, facilitate trade, and improve daily life, demonstrating that his engineering vision always had a practical and social purpose. He also designed an ideal city with separate roads for pedestrians and carts, an advanced sewage system, and architecture that balanced beauty and functionality, an urban dream that anticipated the needs of modern metropolises by centuries. If there was one dream that obsessed Leonardo more than any other, it was flight. He spent years studying the anatomy of birds, dissecting wings and analyzing air currents, convinced that man could replicate nature through mechanics. His notebooks are full of designs for flying machines, the result of a maniacal analysis of the mechanics of flight. The Ornithopter, his winged flying machine, was based on the flapping of wings. Although unfeasible with the human muscular strength available at the time, the project contained fundamental aerodynamic principles that would only be rediscovered centuries later. Leonardo had understood the need for a large, light-wing surface and a propulsion system that generated lift. But two of his aerial inventions are surprisingly modern and practical. The parachute, described as a tent of starched linen with a pyramidal base, was a project so effective that it has been replicated and successfully tested in modern times. His intuition about air resistance and the need for sufficient surface area to slow the fall was perfect. And then there was the aerial screw, a rotor that was supposed to screw itself into the air. It was the basic concept of the helicopter, an idea that only lacked a sufficiently powerful engine to become a reality. His understanding of lift and aerial propulsion was astonishing for the time, and it demonstrates how his mind was constantly projected toward the future. Not only the air, but also the water deeply fascinated him. He designed complete underwater equipment with respirators, fins, and even a system to break the hulls of enemy ships underwater. His mind knew no boundaries, neither high nor deep. He studied currents, waves, and erosion, laying the foundations of modern geology and hydrodynamics. He observed fossils on the mountains and deduced that the Earth was much older than was believed, challenging the religious doctrines of the time with pure scientific observation. After the fall of the Sforzas and the French invasion of Milan, Leonardo returned to Florence, where he clashed with the new rising star, Michelangelo Buonarroti. The artistic rivalry pushed Leonardo to perfect his understanding of the human body, believing that only a perfect scientific knowledge could lead to true art. He performed hundreds of dissections, often in secret, far surpassing the medical knowledge of his time. His anatomical studies were not just drawings, but medical atlases of surgical precision, which could have revolutionized medicine if they had been published. He drew the heart, the vascular system, the muscles, and the skeleton with a fidelity that would not be equaled for centuries. His study of the fetus in the womb is still considered a masterpiece of scientific and artistic observation today. His obsession with anatomy was driven by the conviction that the artist must know the inside of the body to be able to represent the outside with truth and movement. It was during this period, between 1503 and 1506, that he painted the most famous portrait in the world, the Mona Lisa, or La Gioconda. It is not just a painting, but the pinnacle of his fusion of art and science. He used the sfumato technique, a subtle mist that blurs the contours, making Lisa Gherardini's smile eternally ambiguous and elusive. The smile disappears and reappears depending on where one looks, an optical trick based on the scientific understanding of human vision. The Mona Lisa is not just art. It is an experiment in perception, an investigation into the nature of light and shadow, and the ability of the human eye to complete what is left undefined. The landscape in the background, with its aerial perspective, demonstrates his profound knowledge of geology and the atmosphere. Leonardo's final years were marked by political instability and continuous travel. He worked for Cesare Borgia as a military engineer, traveling and mapping territories with a cartographic precision never before seen. His obsession with water led him to study currents, waves, and erosion, laying the foundations of modern geology. In Rome, he was treated with respect, but his mind, increasingly focused on pure science, clashed with the artistic environment dominated by Raphael and Michelangelo. In 1517, Leonardo accepted the invitation of the young King of France, Francis I, who appointed him first painter, engineer, and architect to the king. He moved to the Chateau du Clos-Lucé in Amboise, taking with him his 3 masterpieces and, above all, his notebooks. He spent his last years reordering his studies, drawing projects for the court, and conversing with the king who revered him. He died on the 2nd of May, 1519, leaving a legacy that far surpassed his fame as an artist. What is the impact of a man who designed the future? It is in every machine that flies, in every tank that moves, in every bridge that stands. His influence is not only artistic, but profoundly technological and scientific. Here is a list of his most astonishing visions that have shaped the modern world. The Ornithopter flying machine, the detailed design of a machine that flaps its wings, anticipating aerodynamics, and the very idea of mechanical flight. It is the fundamental inspiration for aviation. The parachute, a drawing of a pyramidal structure in canvas, a concept so perfect that it was replicated and proven functional centuries later. The armored tank, self-propelled cart, a human-powered armored vehicle with cannons, the conceptual prototype of the modern tank and mechanized warfare. Underwater equipment, designs for respirators and fins, precursors to diving equipment, and modern wetsuits. The aerial screw, the drawing of a device with a large rotating propeller, the basic concept of the helicopter, although not feasible with the technology of its time. The self-supporting bridge, a structure that stands without external fixings, an example of advanced structural engineering and an idea still used in architecture. Anatomical studies, detailed drawings of the human body which revolutionize the knowledge of anatomy and physiology, surpassing the limits of the era. The 33-barrel cannon, a rapid-fire weapon, a kind of primitive machine gun which anticipates repeating weapons. The robot knight, the design of a humanoid automaton capable of moving and gesturing, one of the first examples of humanoid robotics and programmable mechanics. The ball bearing, although not a single spectacular invention, his design of the ball bearing is fundamental for reducing friction and made the entire Industrial Revolution possible. The drop hammer, a mechanism for automatically forging metals, a precursor to industrial machine tools. The improved printing press, designs to improve the efficiency of printing, a crucial contribution to the dissemination of knowledge. The speed counter, a mechanism for measuring distance traveled, essential for cartography and military logistics. The hydraulic hammer, a system for harnessing the force of water to operate heavy machinery, a crucial step toward industrial automation. The revolving bridge, a bridge designed to be quickly deployed and retracted, demonstrating his mastery of mobile military engineering. Leonardo da Vinci was not just a genius. He was a bridge between the past and the future. A man who taught us that true knowledge does not lie in the separation of disciplines, but in their fusion. Art is science made visible, and science is the art of understanding the world. And perhaps his greatest secret was not hidden in the mirror writing, but in the simple, inexhaustible question that guided his entire life. How does it work? The magnitude of Leonardo lies not only in the quantity of his inventions, but in the methodology he applied to every field of study. His philosophy was simple yet revolutionary. Knowledge comes from experience, and experience is the result of incessant and meticulous observation. For Leonardo, nature was the supreme model, and mathematics was the language to describe it. No human investigation can be called true science if it does not pass through mathematical demonstrations, he wrote in his notebooks. This fusion between the empiricism of the observer and the rigor of the mathematician places him as a true precursor of the modern scientific method centuries before Galileo and Bacon. His obsession with water, hydrodynamics, is a perfect example of this methodology. He did not limit himself to designing canals or locks. He studied wave motion, the formation of vortices, the erosion of banks. His drawings show an almost mystical understanding of turbulence and laminar flow, phenomena that modern physics would only formalize much later. He designed dredgers and machines for cleaning ports, systems of mobile dams, and floating bridges, all based on a deep understanding of the natural forces at play. In the field of mechanics, Leonardo was an absolute innovator. Many of his inventions were not intended for immediate use, but were solutions to problems that humanity had not yet fully recognized. A striking example is his design of the ball bearing. Although not a spectacular invention like a flying machine, the ball bearing is a fundamental component of modern engineering. Its function is to reduce friction between two rotating parts. Leonardo understood that the spheres, touching only at infinitesimal points, would drastically reduce resistance, making machinery more efficient and durable. This principle is the basis of every engine, every wheel, and every precision mechanism. And his intuition was crucial for the advent of the Industrial Revolution. Similarly, his studies on gears and power transmissions are of astonishing complexity. He designed transmission chains, worm gear mechanisms, and epicyclic gear systems, all aimed at converting one type of movement into another with maximum efficiency. His automatic drop hammer, for example, was a precursor to industrial machine tools, a system that used hydraulic force to operate a heavy hammer, automating a process that previously required the brute force of many men. Leonardo's engineering was not limited to machines. His vision extended to architecture and urban planning. After the plague that devastated Milan, he proposed a radical project for an ideal city to Ludovico il Moro. This city was not only meant to be beautiful, but functional and hygienic. It envisioned multi-level roads, a lower level for goods, traffic, and services, and an upper level for pedestrians and residences. This concept of traffic separation is a fundamental principle of modern urban planning, adopted only in the 20th century. His architecture was based on modularity and symmetry, influenced by his study of the Vitruvian Man, which saw the human body as the perfect measure of the universe. He designed centrally planned churches, impregnable fortresses, and palaces that combined Renaissance elegance with engineering solidity. His project for the dome of the Milan Cathedral, although not realized, demonstrates his profound knowledge of structures and material resistance. Anatomy for Leonardo was not a hobby, but a necessity. He believed that an artist could not represent the human body in motion, in its full emotional and physical expression, without knowing its internal structure. This conviction led him to perform over 30 dissections of human corpses, a risky act often prohibited by the church. His anatomical drawings are of a precision that far surpasses the medical texts of his time. He did not limit himself to drawing bones and muscles. He studied the function of organs, the circulatory system, the mechanics of respiration. He was the first to correctly describe the human spine and to draw the chambers of the heart with almost modern accuracy. His studies of the fetus in the womb, based on the observation of animals and deduction, are a masterpiece of scientific observation. If his anatomical atlases had been published at the time, they would have anticipated medical science by centuries. His research was so far ahead that his drawings remained the most accurate source of anatomical knowledge until the 18th century. His curiosity also extended to deep time. During his travels, Leonardo observed rock formations and fossils embedded in the mountains. Contrary to the biblical belief that the Earth was only a few thousand years old, Leonardo deduced that geological processes, such as erosion and sedimentation, required immense time. Observing marine fossils on the peaks, he concluded that the mountains must have gradually risen from the seabed, an intuition that anticipated the theory of plate tectonics. His understanding of geology was inextricably linked to his hydrodynamics. He understood that water was the great sculptor of the terrestrial landscape, and his studies of rivers and valleys are a detailed analysis of how water shapes the world. Despite his aversion to war, Leonardo was a first-rate military engineer. In addition to the tank and the 33-barrel cannon, he designed innovative defense systems. His drawings of fortifications show angular bastions and inclined walls designed to deflect cannonballs, a concept that revolutionized military architecture. He also designed more subtle and ingenious weapons, such as the revolving bridge, a light and quickly deployable bridge ideal for crossing rivers during military campaigns, and the submarine, an underwater vessel for stealth attacks, which he did not build, fearing that the wickedness of men might use it for destruction. Leonardo's death in 1519 was not the end of his story, but the beginning of a long and unfortunate oblivion for most of his scientific studies. He left his notebooks to his faithful pupil, Francesco Melzi. After Melzi's death, the codices were dispersed and dismembered. Some ended up in private collections, others were cut and rebound in a disorderly fashion. The Codex Atlanticus, The largest collection of his drawings and writings was rebound in 12 volumes, mixing studies of botany with designs for war machines. This dispersion meant that his scientific and engineering discoveries remained unknown for centuries. While his paintings, such as the Mona Lisa and The Last Supper, made him immortal as an artist, his scientific genius remained hidden until the 19th and 20th centuries, when scholars began to decipher and reorder his codices. When the world finally discovered the breadth of his visions, it was an epiphany. It was understood that Leonardo was not just a brilliant painter, but a man who had anticipated the industrial age, aviation, modern medicine, and much of mechanics. Leonardo da Vinci was not just a genius, he was a bridge between the past and the future. A man who taught us that true knowledge does not lie in the separation of disciplines, but in their fusion. His life is a warning against excessive specialization. He saw the world as an integrated system, where the anatomy of the human body was reflected in the architecture of a building, and the flow of a river was analogous to the flow of blood in the veins. Art is science made visible, and science is the art of understanding the world. And perhaps his greatest secret was not hidden in the mirror writing, but in the simple, inexhaustible question that guided his entire life. How does it work? This question, posed with the curiosity of a child and the mind of a titan, has shaped our world in ways we are still discovering. Leonardo da Vinci is not just a historical figure. He is the embodiment of human curiosity, the eternal symbol of the universal man. Summary of key inventions that shaped the future: the Ornithopter, the detailed design of a machine that flaps its wings, anticipating aerodynamics and the very idea of mechanical flight. It is the fundamental inspiration for aviation. The parachute, a drawing of a pyramidal structure in canvas, a concept so perfect that it was replicated and proven functional centuries later. The armored tank, self-propelled cart, a human-powered armored vehicle with cannons, the conceptual prototype of the modern tank and mechanized warfare. Underwater equipment, designs for respirators and fins, precursors to diving equipment and modern wetsuits. The aerial screw, the drawing of a device with a large rotating propeller, the basic concept of the helicopter, although not feasible with the technology of his time. The self-supporting bridge, a structure that stands without external fixings, an example of advanced structural engineering and an idea still used in architecture. Anatomical studies, detailed drawings of the human body, which revolutionized the knowledge of anatomy and physiology, surpassing the limits of the era. The 33-barrel cannon, a rapid-fire weapon, a kind of primitive machine gun which anticipates repeating weapons. The robot knight, the design of a humanoid automaton capable of moving and gesturing, one of the first examples of humanoid robotics and programmable mechanics. The ball bearing, fundamental for reducing friction, it made the entire Industrial Revolution possible. The drop hammer, a mechanism for automatically forging metals, a precursor to industrial machine tools. The improved printing press, designs to improve the efficiency of printing, a crucial contribution to the dissemination of knowledge. The speed counter, a mechanism for measuring distance traveled, essential for cartography and military logistics. The hydraulic hammer, a system for harnessing the force of water to operate heavy machinery, a crucial step toward industrial automation. The revolving bridge, a bridge designed to be quickly deployed and retracted, demonstrating his mastery of mobile military engineering. The ideal city, an urban planning project with multi-level roads and advanced hygienic systems, which anticipates modern urban planning. The intuition that the Earth was much older than was believed based on the observation of fossils and erosion. The coin minting machine, a precision mechanism for the serial production of coins, an example of process automation. The automatic weaver, a design for an automatic loom which prefigures automation in the textile sector. The magnifying glass, studies on optics and the refraction of light that led to the design of lenses for close observation. The true greatness of Leonardo da Vinci, beyond his inventions and masterpieces, lies in his inexhaustible capacity for synthesis. He did not see the world in watertight compartments, but as a single, magnificent work of art and engineering. This holistic vision is what makes him the archetype of the Renaissance man and a beacon for all humanity. His influence extends far beyond the boundaries of his time. Consider, for example, his impact on the philosophy of science. Leonardo was a fervent supporter of direct observation, a radical empiricist in an era still dominated by the authority of ancient texts. His maxim, "Wisdom is the daughter of experience," is a battle cry that anticipates the scientific revolution. He accepted nothing on faith or tradition. Every statement had to be verified, every phenomenon studied at the source. This methodology, which blends the keen eye of the artist with the analytical mind of the engineer, is his most enduring contribution to human thought. Consider the cultural impact of his codices. Although unpublished, his drawings and notes have indirectly influenced generations of thinkers and artists. His aesthetic, based on the golden ratio and sacred geometry, has been absorbed by architecture and design. His study of light and shadow, sfumato, transformed painting, making it no longer a simple representation, but an investigation into perception and emotion. His fascination with water, which led him to design hydraulic systems for irrigation and navigation, reflected a deep ecological awareness. Leonardo saw the interconnection between man and the environment. His studies on deforestation and soil erosion are surprisingly modern, demonstrating an environmental sensitivity that has only become crucial in our century. He was not just a builder, but a custodian, a man who sought to harmonize human intervention with the immutable laws of nature. Finally, his figure remains a symbol of intellectual freedom. Born out of wedlock, self-taught, left-handed, and with mirror writing, Leonardo challenged every social and academic convention. His life is proof that genius knows no barriers of birth or formal education. He encourages us to explore, to doubt, to never stop asking questions. His legacy is not just a catalog of unrealized inventions, but an invitation to live with boundless curiosity. Leonardo da Vinci is the man who demonstrated that imagination, when supported by reason and observation, is the most powerful force in the universe. His story is the story of a man who, while living in the Renaissance, left his indelible mark on every century to come. His work is a continuous dialogue between man and the cosmos, an eternal search for truth that continues to inspire and amaze. Leonardo da Vinci is not just a historical figure. He is the embodiment of human curiosity, the eternal symbol of the universal man. His legacy is the demonstration that true progress lies in the ability to see the whole, to connect the dots, to unite the useful with the beautiful, engineering with ethics, mechanics with philosophy. He is the man who designed the future. His life teaches us that observation is the key to unraveling the mysteries.